This is a video on overloading, const, and static. Disclaimer: by watching this video you agree not to sue for mental anguish. Overloading is when you have two or more procedures with the same name but different parameters. Parameters can differ in number, data type, or both. Return data types are not significant to the compiler. That means you can't have two procedures that are exactly the same except for the return data type. You'll get a multiple definition error. Here's a very simple example. Same procedure name, add two values. The first one, there are two parameters, they're both integers, and the second one, there are two parameters and they are both float. These procedures both do the exact same thing except they return nothing. Hold on, let me fix that real quick. Okay, got the data types fixed. And that's just a very simple example of overloading. Now, why overload? Because it makes it easier on any programmer that's going to use the code. And usually that's you, so it is a worthwhile investment in time. Now, a common use of overloading is to simulate VB's optional parameters. In the review video for C-sizable array homework, I had two print methods. One procedure had no parameters and the other took a char pointer as a parameter, and that char pointer was used as a caption. The first version called the second one with the default caption. In VB.NET this would have been implemented as print optional str caption as string equals print array. So if you don't specify anything, it's going to supply print array for you. If not, if you do supply something, it'll use that instead. C++ allows you to overload not only custom procedures that you write, but built-in operators like plus equal and the subscript operator. That's what the bracket. According to the book, these are all the operators you can overload. And if you look, that's in table 11.1, so you can find that in the book. The book kind of scatters the material around. It talks about overloading in, I believe, chapter 8 for classes, and then it talks about, that's function overloading, and then it talks about operator overloading in chapter 11. So the pieces are kind of spread out. But anyways, there's a ton of different things you can do. Now, in all my programming experience, the only time I have ever overloaded operators was for the homework in this class and the C++ programming courses I took in college. It's a very cool concept, but it just doesn't get used much in business database programming, which is where most of the job opportunities are. The syntax for overloading operators is the return data type, the keyword operator, the actual operator itself, and then any parameters. And technically the parameters are optional. So for example, if we have void operator plus equal, and we are going to append an existing array. Now we pass that in by reference. That's what the ampersand means. Remember that. And by the way, anytime you see the acronym CRA in this video or other videos, that is an abbreviation for C resizable array, and I did that in the videos for purposes of readability. So I was following the spirit of law rather than the letter of the law. And we take that in as a constant, and so that means inside the procedure we will not be able to change that instance at all. And how that might be used is assuming that values 1 and values 2 are both instances of C resizable array. You could say values 1 plus equals value 2, and it would append all the entries in values 2 to the end of values 1. And that's a big deal because it has to allocate new hunk of memory, copy the old values, and then get the other values from the other array, and then delete the old memory for values 1. It's a big deal. Now the parameters are optional, but if you're overloading, it's highly unlikely you need or make a non-parameterized version. There is of course an exception. Most operators are binary operators, meaning that they take two parameters. In the above example, the plus equal operates on a class instance on the left and a class instance on the right, so it takes those two in. There are unary operators, for example plus and minus, that don't take parameters, and obviously you can overload those as well. If one of the parameters passed into the overloaded method is not the same data type as the class itself, The friend keyword must be applied to the method declaration. Notice just the declaration, not the definition, to allow the other data type to access the private class properties and methods. So for example, in this first one, I have the parameter, the array to append, is the same data type as the class in which the method is defined, see resizable array. Therefore, the keyword friend is not needed. However, if we want to append a single long value, that's a different data type than the class in which the method is being declared. Alright? So, in order to do that, we have to have the friend keyword in order to access any non-class data types. So, it's a little more complicated than you could read up in the book if you want and actually bust out some examples. Again, it is very cool, but of limited use. Email or call if you can find a good practical business example of operator overloading. I'd love to hear about it, and I'll buy you lunch and we can talk tech. Now, just some notes. As I said, overloading is useful, but it's not used a lot. Don't fall in love with the tool, and don't try to do something in code just because you know how. Always do a cost-benefit analysis and use the right tool for the job. The const keyword prevents a programmer from changing whatever the const keyword modifies. In other words, you can't touch it. Const can be used in 3 different ways, hence the caption for these slides. Application number 1. The const keyword can be used to modify a variable. For example, const int array size equals 100, and it turns it from a variable into a constant. If you try to modify a constant, you will get a compiler error. Now, you might not know this, but const can also be applied to procedure parameters. So for example, copy string, char pointer, PSTR destination, const char pointer, PSTR source. Now what that means is if you try to change the source parameter in any way, shape, or form inside that procedure, or any sub-procedures that it calls, you'll get a compiler error. Now most string functions in C and C++, like string copy, string link, take constant char pointers for the source parameter. The calling procedure can change the variable, but the called procedure cannot. Application number 2. The const keyword can be used to modify a function return value. For example, const char pointer cdog : get name return, and then we return that string. Now if you give a C or C++ programmer a pointer, he's going to want to change the contents of that pointer. Admit it, if you had a pointer, you'd want to change the contents too, wouldn't you? Sure, we all feel that pull. What's it pointing to? What can we change down there? Okay, sometimes it's okay to change the contents at the address, but other times it's not. We would not want a programmer to change the dog's name without going through the set name method, because that's where the centralized business logic and encapsulation is. Accessing the pointer directly would bypass all of that, and most of the time in business programming we do not want that to happen. Suppose the memory for the dog's name was dynamically allocated instead of statically allocated. If a programmer bypasses the boundary checking encapsulation logic in the set method or set name method, he could easily corrupt memory. So for example, call set fido, and that dynamically allocates 5 bytes, 4 for FIDO and 1 for the null terminator. Then, if the programmer calls getName, which returns a pointer, and if that's not constant, he could use that in some sort of string copy method or something and copy another string into the pointer's memory location. Well, superFIDO is longer than 5 characters, and that would corrupt memory. That would really be bad. So by making getName return a constant char pointer, it prevents things like that from happening, and you keep those very inquisitive C and C++ programmers at bay and don't let them manipulate your memory. That's why in the C resizable array review video that I did, there was not a getArrayPointer that returned a long pointer. It would be too tempting for programmers. They'd want to get in there and start manipulating things directly. And it always starts off innocently, and the next thing you know, you got some giant spaghetti code. It's just too dangerous. So we encapsulate all our class properties to prevent misuse, which would cause bugs. And remember that bugs in and of themselves aren't so bad, especially in a school environment. It's all the tech support calls that they generate and the loss of work for the customers. So again, in a school environment, it's hard to appreciate that because your phone isn't ringing. But once you start in business, you will. Now, we could make the return data type for the above function a const, but that's still revealing too much about the inner workings of our class. There's no need to show the outside world that we're using a pointer to an array of longs to store the data. So just because we can protect the class property doesn't mean we have to publish or reveal how things are done inside. With classes, reveal only what you absolutely have to. Now, what is absolutely have to and what are criteria for that? Some of that comes with experience, but you're well on your path to learning what to do and what to not to do. So most of the time, just don't expose it or reveal it unless the program won't work without it. Application number 3. The const keyword can be applied to a class method. So for example, long serializable array, : get size, const. Now this must go in both the declaration and the definition. Remember, declaration's the header file, definition's source file. Now the const at the end means the class method will not change any class properties. So if you try to change class property, the compiler will throw an error. You can't call any other class methods from a const class method unless the called class methods are also const. That's because if they're not const, they may change a class level property. So a const class method can call only class methods that are also const. So here's an example. If we have some print method that is defined as const because it's not going to change anything, it's just going to display, we could call getSize if getSize was declared and defined as a const because all it's doing is returning value, it's not changing anything. And we could assign that to a variable, a local variable, which is fine. We can change all the local variables that we want, and we could even add one to that. However, we can't call setSize because setSize is definitely not const. It's going to be allocating memory and changing a pointer and a long variable, and because it's going to be changing that, we can't declare it as const. Therefore, you cannot call setSize from the const print method. Now, any non-class procedure can be called as long as they don't take class properties as non-constant parameters. So for example, we can call printf inside our code with getName, and that's fine because that's a constant. It takes that as a constant parameter. However, we cannot call string copy with getName as the destination because the destination is non-const. Pretty straightforward. We may be asking, how come I can't make constants inside a class? Well, I will show you. You may have been tempted while doing the CDOG and TrainDog homework to make a constant for your string sizes and use that in not only your declaration of your variables but also in your set methods. However, if you try to put a const in there, it blows up. You get a whole bunch of undeclared identifiers, and then here the telltale sign very at the bottom, only static const integral data types can be initialized within a class. So we put the keyword static there and then build. It succeeded. Suddenly everything works. So we can have constants as long as we use the static keyword. Now, why didn't it work without the static keyword? It's because you're assigning a value to the constant, and because a class is a blueprint. You can't put carpet inside a blueprint, you can't wallpaper a blueprint, you can't park your car inside a blueprint. The compiler won't let you assign a value to anything. Well, technically can, but there's a trick that we haven't gone into yet, but for the most part you can't. You have to make an instance before you can assign a value to anything. So you have to build a house from the blueprint before you park your car in it or carpet inside. However, if you use the static keyword, you can make constants inside the class. And the static keyword can be applied to either class constants, class properties, procedure variables for classes, or class methods themselves. A value in a static class constant is shared by all instances of that class, and it functions just like you'd expect. So if we have cdog, static const long, string maximum size, we can use that everywhere inside our dog class and make it happy. Now if you want to use that in any inherited methods or in any inherited classes, you have to make it either protected or private, because it defaults. Oh no, you have probably to make it protected or public because it defaults to private. A value in a static class property is shared by all instances of that class and functions differently than you might expect. If you make any class property static, all instances share the exact same variable, and the example I like to use is C-joint checking account. So let's say you make two instances, his and hers. If each make a debit, then it comes out of the same balance even though it's two different instances. Very interesting. Cool, and it has some fairly practical use to it. And here's a little example to illustrate that. So we've got his and hers, both instances of a joint checking account. His deposits 100, hers she withdraws 50. His, he gets the balance, it's going to print out 50. Even though they're different instances, balance is shared. Now static procedure variables are initialized only once, and the value and the contents are preserved even after the procedure ends. So for example, this is inside a class, and this is a local procedure variable to that class. If you make that variable static, it's going to be initialized once and only once, and it will maintain its value even after the procedure ends. So if it's called multiple times, print count is going to keep incrementing and getting up, going higher and higher. Now I believe, I haven't actually used this, I believe that is private to that instance. So each instance gets its own local copy of print count. Now that can be very useful for debugging or getting the next highest value or object reference counts, but most of that is high level and won't be needed anytime soon. If, again, I'll put a bounty out on this, if you find a really good business example of that that's practical, it's just not some really strange rare occurrence, but if a practical use for that, let me know. I'll buy lunch and we'll sit and talk tech. The purpose of making a static class method is you can therefore call that method even without making an instance. Now static class methods have some restrictions. They can call only other static class methods, and they can access only static class constants, static properties, and local procedure variables. Making all the properties and methods in a class essentially turns a C++ or Java class into the equivalent of a VB.NET module, which can be very useful. Anyone who's taken VB2 or VB3 from me knows about mod utilities and mod database utilities. A module in VB.NET is a class with one and only one instance. And then the really nice thing is that it has global scope if you make it public and can be accessed from anywhere in the project. Now that's not a bad thing as long as you follow the coding standards for encapsulation. It's safe to do. The side effect is that you don't have to pass around an instance to every procedure in order to use something like write log or call a database procedure. So let me show you examples of that. If you've had me for VB2 or 3, you'll know this code will look very familiar to its teams and players. If you've had SQL 1 and you looked at the very extra credit at the end about write log, you'll notice that I use try catch with write log in every procedure. Now I can use write log everywhere because it's in a module. It's in mod utilities down here at the very end. It is in write log, and I can call that without having to make an instance, which is extremely useful. And all my all my module properties are private. So let me go show you that. You notice that those are private, and that means I'm following all the coding standards and the rules for encapsulation, so everything is really good. So that's in Visual Basic, but to do the equivalent in Java or Eclipse, we have to use a static class properties and methods. So here we are in Eclipse. Sorry for the detour, but you'll notice I've got C utilities, and we'll look at the source code for that. And let me change the divider. You'll notice it is a public class, C utilities, but it's static properties and static methods. And way at the very bottom, one of the things that we want is write log. And we have one that takes, we do some overloading. So we have one that takes an exception, and one that takes a string, and one that takes an exception and a display. And so in all these, what they do is they dump write log, or they write the message to a log file, which is extremely useful. However, in the rest of my project, so we'll go to something like main, I want to be able to call that. So I use my try catch, and in my catch I say the class name and then the static method, and that way I do not have to make an instance, which would be extremely cumbersome if I had to pass that around to every function call so it would be available. So you notice it's everywhere. Very, very useful to have static class methods and properties. So I was talking about how you can emulate that in modules in Java and C++ using static. And for those of you that didn't take Java 1 from me, don't worry, we're going to do the exact same thing in C3. So when you take the third C class, you will get to have a C utilities and a C database utilities, and you'll get to experience those firsthand. In summary, overloading is the same procedure name but different parameters. If you have the keyword const before a procedure return data type, that means the calling procedure can't change the returned value, and if it's a pointer, the calling procedure can't change the contents at the pointer address. If you have const before a parameter in a procedure, then the called procedure can't change the value. The calling procedure can, but the called procedure can't. If you have const after the procedure name, that means the called class procedure can't change any class properties. And finally, the static keyword. There's one and only one copy of whatever it is, no matter how many instances, even if there are no instances. And it can be accessed at any time, even if there are no instances, by using the class name and the property method name. So for example, cutilities.writeLog. And that's the end of this video. Yo, sound the bell. School is in.